Okay, these are your notes for lesson 2. Today we're going to talk about color. And I'm going to start by reviewing a couple of the ideas we talked about last time. So first of all, we talked about how the human eye is only able to see in a certain frequency and wavelength range. Red, orange, yellow, green, blue, indigo, violet. These colors represent the wavelengths of the electromagnetic spectrum that we are able to see. We also talked about what that range was. It's from about 400 nanometers. So over here on the short end of the wavelength, here's short wavelength, high frequency, to 700 nanometers over on the red end. These are the longest waves and the lowest frequency. And we talked about a nanometer is 1 times 10 to the negative ninth meters. That's 1 billionth of a meter. So as you go from red through the colors to violet, you are getting shorter in wavelength and higher in frequency. So over here to the left of red, just before red, we have infrared and then microwaves, and on the far left end we have radio waves. Over here to the right of violet we have ultraviolet and then X-rays, and the far right end, the shortest and highest frequency, is gamma rays. We also talked about the simple fact that all of these colors, all the light waves, and all the different types of waves we learned about on the EM spectrum last time travel at the same speed, 3 times 10 to the 8th meters per second. That's the same as 300 million meters per second. Now we're going to talk about something you probably already know a little bit about, mixing paint colors together.
All right, here you can see something that you're probably very familiar with, most students are. I took some basic watercolor paints, and over here I got red, and way over here I got, well, this one was a mistake. Right here I got basically purple, violet. But with colors of pigment, most of you know that if you want to make orange, this is as close to orange as I could get, you got to mix red and yellow. And most of you know that if you want to make green, you got to mix yellow and blue. And most of you also know that if you want to make purple, you'd have to mix red and blue. And if you mix them all together, you get black. Well, that's with pigment. That's with colors of pigment. With colors of light that overlap, the addition of color works very differently, and the rules are not the same.
Mixing light works totally different than mixing pigments. So over here, you mix yellow and a color like this, which we call cyan, and you get green. If you mix yellow and this color magenta, you get kind of a reddish orange, you get red. If you mix magenta and cyan, you get blue. So these outer colors are actually the primary colors of pigment. You've got cyan, yellow, and magenta. And if you overlap them, you get red, green, and blue. And if you overlap all of them, you get black. This is how your color crayons and your paint work. Over here, you have kind of the opposite. Light, when combined, adds up differently than pigment. So the primary colors of light, and you'll see this if you adjust the settings on any computer monitor or television screen, you get any color on the TV screen by adjusting the levels of red, blue, and green. So by overlapping the primary colors of light, we get to the primary colors of pigment. In other words, red plus blue gives you magenta, red plus green gives you yellow, blue plus green gives you cyan, and if you overlap all of the primary colors of light, you get white light. Here's another look at it. You can kind of see these are flashlights that have the primary colors filtered over them. So this is red light, blue light, and green light, and where they overlap on the wall, you see these colors that we just discussed, and where they overlap all together, you see white. Please write these down in your notes over here. Red plus blue equals magenta, blue plus green equals cyan, red plus green equals yellow, red plus green plus blue equals white. You'll need these for the activity that you're going to be doing later and to answer the questions on your assignment. Now this stuff is all very counterintuitive because of your experience with pigment. When you colored paints together as a younger student or even in art class, it doesn't work this way. Light is different than pigment, so that's what we're learning about today.
All right, so here's a little preview of the interactive you're going to be playing with today. Over here on the left it says a shirt appears red when red light shines on it, and the same shirt appears blue when blue light shines on it. That's right here. what color will this shirt appear when magenta light shines on it? Well, as you've learned, magenta is just the combination of both red and blue light. And since they are both reflected, what we should see is that they will reflect the color magenta. Let's see if we got it right. Hey, there we go. Here's another example. On the left it says that a shirt appears red when red light shines on it, and when the same shirt has blue light shined on it, it appears black. So in other words, blue gets absorbed. Since magenta is the combination of red and blue, but only the red gets reflected, what you should see is just red. Okay, so that's how that works. Here's another example. A shirt appears black when blue light shines on it, so blue gets absorbed. The same shirt appears green when green light shines on it, so green gets reflected. Here, cyan light is shining on the shirt. Cyan is the combination of blue and green, but only the green gets reflected, so we should only see green. There you go. That's how color addition and subtraction works. So now you've got an idea for how to do this. When you get to the interactive, you should know what to do.
Now there's just a preview here of the different parts of the eye. But the main idea here, and we'll talk more about this next class, is that your eye has different cells. It has rods and it has cones. They each have a specific function, but your cones are what allow you to see color. So we'll talk in more detail about how your eye allows you to render reds, greens, and blues on your retina by taking advantage of your cones. That concludes the notes for today.
And this is what I have written for my notes. Everything we talked about, written in my own way, maybe just with a couple things added. Go ahead and pause it here if you want to copy this.